Do you all recall what Myoku had remarked last year after extremely early galaxies showed up in Webb images? Well, that's the difficulty that James Webb Space Telescope is disturbing the apple cart. All of a sudden, we realize that we may have to revise all the textbooks regarding the beginning of the universe. Now, it takes many billions of years to generate a galaxy like the Milky Way galaxy with 100 billion stars, many billions of years old. But the James Webb Telescope has detected 6 galaxies that live half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only half a billion years old. Something is wrong. We may have to alter our hypothesis of the creation of the universe. At this time, I don't think anyone is anticipating anything else than new from the James Webb Space Telescope. These are exciting times. We are living in an era that will see a significant transformation in cosmology. Every giant was once a baby, though you may never have seen them at that point of their development. NASA's most powerful space telescope is revealing information on the early years in the history of the cosmos that was well beyond our reach until now. In June 2022, the James Webb Space Telescope detected plenty of faraway galaxies when it first acquired its deep field photograph. Suddenly, galaxies started to peek forth from the blackness of time and space, unveiling themselves. The universe, for the first time, started to seem considerably stranger than we ever expected it to be. Galaxies formed from what we assume to be the universe's dark ages, casting issues regarding the science of our cosmic model. And it wasn't just a couple of galaxies. The Webb telescope discovered hundreds of them. One of these galaxies was discovered by Austin astronomer Stephen Finlin and lovingly called M's galaxy after his daughter when they spotted it on her birthday. Initially, the scientist and his team assumed that the galaxy had originated practically immediately after the Big Bang on cosmic timescales, calculating its age to be around 290 million years after the Big Bang. However, with more improved equipment, they later concluded that it is around 100 million years older. Nonetheless, this discovery confirms its title as the oldest galaxy ever observed, forming a mere 390 million years after the Big Bang. Yet, the current title holder for the oldest observed galaxy may not hang on to the leading position for long. The Sears team is presently evaluating roughly 10 other galaxies, which could potentially surpass Ma's galaxy in age. We're witnessing the formation of big galaxies at a speed faster than we previously predicted, said Fao Pui of the Harvard-Smithsonian Center for Astrophysics. Some of these early galaxies are considered to be only tens of millions of years old. This rise in enormous galaxies could have ramifications for the large structures of dark matter referred to as halos, which, in line with current cosmology, sculpted early galaxies. However, some issues exist with particular early universe candidate galaxies remaining problematic and potentially testing conventional models. A remarkable example is a class of galaxies identified by a team of scientists at the Swinburne University of Technology in Australia. The scientists identified galaxies with billions of solar masses rivaling the weight of the Milky Way, stretching back to an estimated 750 million years after the Big Bang. Remarkably, these galaxies are 10 to 100 times larger than those previously detected from this age and are densely packed into formations 30 times smaller than the Milky Way. What adds to the fascination is that these galaxies appear to house a significantly greater number of stars than first considered conceivable. This revelation questions the fundamental underpinnings of our knowledge of how huge objects evolve over time, casting a direct challenge to the accepted cosmological standard model. Not only have we continued to discover more distant galaxies, but lately, the Webb telescope identified Milky Way-like galaxies at the farthest reaches of the universe, testing our understanding of physics, as these galaxies should not potentially exist. Many early galaxies, akin to those observed, were characterized by bright gas that was so brilliant it could outshine the stars developing within them. These recent results provide insight on the predominance of such dazzling gaseous child galaxies when the universe was barely 2 billion years old out of its 13.8 billion year lifetime. Observations reveal that over 90% of these galaxies exhibited severe emission signatures signifying the presence of this luminous gas. While exploring these early galaxies, astronomers accidentally found onto the most distant instance of a galaxy resembling our home galaxy, the Milky Way. Yes, you heard that accurately. When the universe was just 2 billion years old, the newly discovered spiral galaxy Sears 2112 looks to have included a bar of stars and gas cutting across its core. But one would wonder, how is that even possible? Our galaxy, the Milky Way, is a spiral galaxy exhibiting a similar bar structure. Scientists hypothesized that the Milky Way's bar revolves cylindrically, channeling gas toward the galaxy center and sparking episodes of star formation. Traditionally, astronomers assumed that this galactic structure indicated the culmination of a galaxy's formative years, anticipating it to be detected primarily in adult galaxies, potentially those halfway through the universe's evolution. Previous investigations from the Hubble Space Telescope, which focused on galaxy morphologies, led scientists to infer that the early universe had very few barred galaxies. However, our knowledge of the early cosmos is undergoing a shift. The latest discoveries derived from data acquired by the Webb telescope question the concept that B-spirals must have emerged just recently in the universe. The finding of spiral galaxies like Sears 2112 implies that galaxies resembling our own were already in existence approximately 12 billion years ago, when the universe was barely 15% of its present age. Yes, Southeast 2112 is observed at a redshift of 3 when the universe was 2,100 million years old, suggesting that the light from the galaxy took nearly 12 billion years to reach the James Webb Space Telescope. This discovery is remarkable considering galactic bars found in the galaxy were previously considered to have originated roughly 4 billion years into the universe's existence. The conventional model of cosmology predicts that the physical circumstances of the early universe should have hampered the formation of such barred galaxies in general. Nevertheless, here we are confronted with facts questioning these expectations. Even theoretical predictions from cosmological simulations struggle to duplicate such systems during those epochs. This poses the essential question of identifying the fundamental missing physical ingredient in our models, if only anything is genuinely missing, remarked one of the experts associated with the discovery. Now, for the exciting twist, scientists propose that 85% of all stuff in the cosmos is dark matter, a mysterious element that stays elusive to observers since it doesn't interact with light. Dark matter is considered to have greatly influenced galaxy evolution and star formation from as early as 380,000 years after the Big Bang. However, the data from this new discovery show that galaxy evolution, at least in the instance of Sears 2112, was largely driven by ordinary matter and not dark matter when the universe was roughly 2 billion years old. Indeed, it's an important discovery indicating that the evolution of this galaxy was largely impacted by baryons, the conventional stuff that makes you, me, and everything we see, rather than dark matter. Despite its pervasive presence, the secrets of the universe are now within our reach. What do you guys have to say? Drop in your comments.